Unfortunately, I don't know Korean, so I'm going to do this in English. Those of you who can follow along, great. Those of you who can't, we have some AI translators. Thankfully, we are at the AI Summit. My name is Renen Hallak. I'm founder and CEO of VAST Data. First and foremost, thank you for having me. I'll try and explain what VAST Data is, what we do, and how we fit in to this AI ecosystem. The operating system for AI is what we build, but first and foremost, we should start with Korea because we are in Korea. I saw Jensen came last week, had some fried chicken, made some big deals and announcements. And of course, I find myself almost every week in a different country. I'm here today, I'll be in London next week. I travel the world and I find that different countries have a different attitude towards AI. Some embrace it, some are scared of it, some are early adopters, others wait for others to try it out first. And Korea is definitely in the early adopter camp. We're seeing very, very large AI clusters, not just be announced, but get built. 50,000 GPUs per cluster, hundreds of thousands of GPUs are coming to Korea. And that is, of course, in part because of the government pushing this, and in part because of private enterprises and AI clouds starting to form. Speaking of AI clouds, we at VAST Data are powering almost all of the AI clouds around the world. If you look at CoreWeave and Lambda and Crusoe and Core 42 and Nebius and all of these AI clouds that most of which did not exist a year ago or 2 years ago are now leveraging the VAST AI operating system as their storage solution, as their data platform, as their software infrastructure stack, such that they can provide cloud services, AI cloud services to their end users. And so we're extremely humbled and proud to be here in Korea, powering the biggest AI clouds that you have locally. But before going into that, maybe we should say a few words about who VAST Data is. Over the last 10 years, we've been building this company, and we've broken record after record after record. We started as a storage company and very quickly morphed into providing the full software infrastructure layer for AI. We are the fastest to get to $2 billion. This slide is actually a little bit old. We have way surpassed that number over the last few months. And as we grow on this exponential curve, we keep breaking more and more records. We have a new architecture. Our biggest advantage is that we started late. And so we built what we call disaggregated shared everything. It's an architecture that was built for AI and is enabling AI at the largest scale. Today, the VAST Data Platform is connected to more than 2 million GPUs from NVIDIA and other hardware providers, the largest clusters in the world, whether you look at xAI or CoreWeave, are powered by VAST. And wherever there is AI compute by NVIDIA and other chip companies, there is usually AI data powered by VAST. You saw up there a few of the Cloud 100 and Innovator awards that we've received. We have a marketing department now, and so they're getting us on all of these lists. But 10 years old, started in 2016, 1,200 employees, building very, very fast, tripling in the last few years, quadrupling even year over year. So very, very fast growth, but at the same time, very efficient growth, generating cash pretty much since we started selling, headquartered in New York City, that's where I'm from, with a big chunk of our R&D team out of Tel Aviv. What is it that we do? Our mission is to transform data into action. As autonomous driving cars drive around and collect footage, video data. Those pictures come into a system, and that comes with context. Where was that picture taken? When was it taken? What camera, what car, what resolution? All of that metadata is stored in our platform. And then we run that picture through an inference function, and we understand what's inside of that picture. And we see a person or a stoplight or something in the road, and that accumulates as more metadata. And then we can take action. And so we understand what's in the data, and then we take action based on what's in the data. We saw a person in a certain geographic location. We need to do something with that. And that introduces more metadata, and then we have more action to take. And all of this information that comes into a system, you want to not just infer on it and understand what's inside of it, you also want to train and build a better AI model. And when you have a better AI model, you want to re-infer on all of your history to better understand what you have. All of those pipelines, all of that interaction and action on data as it comes in across different types of GPUs and CPUs, all of that is handled by the VAST AI operating system. And let's talk a little bit about how we got here. We started almost 10 years ago with a very, very simple idea. We call it DAYS, disaggregated shared everything. What we realized was that the old systems don't scale to the levels that will be required by AI. And if you think back 10 years, AI was at its infancy. The most that AI could do was recognize cats on YouTube videos. But already it was clear that it was relatively old ideas, old algorithms that were showing these results because suddenly they were given very fast access to a lot of information. And DeepMind, Google in those days, or the pioneers, they could do it for themselves. They could build infrastructure that supported that level of scale and that level of performance, but everybody else needed somebody to do it for them. And that's why VAST exists. We built a system that is not for numbers and columns of a database. It is for pictures and video and sound and genomes and natural language. Data that is a lot bigger and much less structured than what came before. It's not built for a few CPUs, but thousands, tens of thousands, hundreds of thousands of GPUs that are extremely hungry for information. And so DAYS is the foundation of all of that. It allowed us to break the fundamental computer science trade-off between price and performance and scale and resilience and ease of use to build one system that is good for all of those things and one system that enables these new AI workloads. 2019, we achieved the vision of what we called universal storage. Because we broke those trade-offs, you could put all of your data on one system and have all of it accessible to these new AI workloads. And then a few years later, we realized that it wasn't just about unstructured data. It wasn't just pictures and video. It also meant that we needed to understand what is in those pictures and in those videos, and that is metadata, representing the underlying information and allowing us to give it structure and to give it meaning and to generate insight from it. So in addition to the VAST Data Store for unstructured data, we built what we call the VAST Database for structured data, where you can now query information using structured query language to see what is underlying, to understand the unstructured data. That transformed our platform from a storage system into a data platform. But what we realized very, very fast is that that's not enough. What we needed is not just a static store of information, a place for applications to write and read data, to write tables and query from a database. We needed a new way of doing computation. Applications needed to be rewritten in a way that is data first, that is data driven. And for that, we built what we call the VAST Data Engine. And that's when we turned into the AI operating system. What do I mean when I say operating system? Well, it's that middle layer between the hardware and the application. And for AI, the entire stack is being transformed. The hardware is GPUs, fast networking, SSDs in racks that are 500 kilowatt with very, very strong power plants next to the data center. The application is no longer old Windows or Linux applications, it's agents and robots and the ability of thinking machines, hopefully soon as we continue to enable these new technologies. And so when we have new underlying hardware, when we have a new type of application, we need that software infrastructure layer to be redone. And that's what we did. We built that operating system in order to take advantage of the latest and greatest in hardware technology underneath us and to enable these new agentic workloads on top of us. What does it look like? And so we have multiple parts to the system. Like we said, we started in the early days by building a storage solution that is faster than the fastest was before, bigger than the biggest was before, very cost effective, very easy to use, extremely resilient, such that you can put all of your data in one system and not worry about it anymore, not think about it anymore. And in the early days, that was okay for organizations that were on the bleeding edge of AI because they were willing to compromise on not having any features or functionality in order to have that good engine. Over the years, we added snapshots and replication and encryption, quality of service, multi-tenancy, all of the different storage protocols like file, NFS and SMB, object, S3, block, NVMe over TCP, so that you can really use our system for all of your data. And a really nice side effect of that is that now all of your data became accessible to these new AI workloads. The VAST database is not just a data warehouse or a transactional database, it's both. It's rows and columns, and it allows you to store not just human readable metadata, but also machine readable metadata like vectors. And then you can run similarity search across those vectors and understand what is underlying your information. The VAST data engine is where it comes to life. And what we did was we implemented, first and foremost, a streaming function with a Kafka interface, such that agents can now communicate with each other using a persistent platform where we can understand what they're doing, what they're talking about. Using SQL, we can ask intelligent questions about the communication between these agents, not just in real time, but going back in time using snapshots, asking, what did those two agents talk about 2 months ago? Or give me all the agentic conversations that included this topic. And so Kafka is the first piece of our data engine, but very quickly we added what we call triggers and functions. That picture that came from the autonomous driving car, that should trigger an inference function that runs on that picture. And when we see a person in a certain geographic region, maybe we're looking for that person. That should trigger another function that alerts that someone was found. All of these pieces come together to build the next computer. And it's not a computer within a physical device. It's not even a computer within a single data center. It is across geographies. The vast data space allows us to run in the public cloud, in the private cloud, at the edge, and eventually in the devices. We are in charge of data placement such that the applications get very fast access to all of the information. We are in charge of data protection such that when things fail, when a data center goes down, when a link goes down, everything is redundant and all of the data is always accessible. Now, that's what took us to this point. Now we're starting to think about agentic workloads. Agentic workloads require all kinds of new security mechanisms. No longer is it just people and data. We now have a new dimension, which is artificial people. And these artificial people, they're now starting to access information. And we need to know, is that agent allowed to see that piece of data? And are they allowed to communicate it to another person or to another agent? Maybe both agents are allowed to see this data, but they're not allowed to know that the other agent can see it. And so they're not allowed to talk about it. All of these things that humans naturally understand, we now need to code into these new artificial humans. And the artificial humans will answer our questions based on their experience over time as they see more things and hear more things. That will fine-tune their models such that each one of them will have their own model of the universe, their own derivative of that foundational model that came from OpenAI or XAI or Inflection or Mistral. And then we need to know which data went into fine-tuning their models, because that data can be leaked when we interact with them. Then we need a way to reproduce. Why did this agent give that response 2 months ago when it was asked this question? All of that is part of this operating system. It's enabling enterprises to deploy AI into production in a secure manner, in a simple manner, in a highly performant and scalable manner. And so as AI makes its way from the research center and the university into the enterprise, into the cloud, into the government agency, this operating system is what makes it widespread. It's what makes it available for all of us to use in production environments. Again, this is just the beginning. Our vision from the very first days was, can we build a thinking machine? And we have not yet been able to build a thinking machine. Today, AI talks to us in natural language, but it only tells us things that we already knew or that somebody somewhere already knew. It does not come up with new ideas. It does not solve problems that we don't know how to solve yet. In order to get there, we need to arm these agents with a few more things that we as humans have today and they don't have yet. One is that ability to fine-tune, the ability to use our experience in order to learn new things. What we do every day is we learn and we apply, we learn and we apply. And the agents too, they will fine-tune and they will infer, they will fine-tune and they will infer. But that's not enough. None of us can think of a new idea all alone in the ivory tower. We need to interact. We need to interact with each other. We need to interact with the natural world. And so giving agents the ability to talk to each other, to misunderstand each other, to brainstorm is a key point in achieving that thinking machine. Giving agents physical access to the physical world. And they're no longer just virtual agents, they're now robots, whether they're four-legged robots or two-legged robots, whether they're a car or a drone, they can go out and understand what's going on, make experiments, see how their interaction with with nature affects what is going on around them. And I think that when we give AI those abilities, it will bring us closer to building that thinking machine. How do we do it? Well, we can't do it alone. We can't do it by ourselves. We today at VAST have partnered not just with AI clouds around the world and with the foundational model builders around the world and with the enterprises around the world that are leaning into AI, but especially in this region, in Asia Pacific. We have customers and partners like LG and Hyundai and Coupang and Ola, Samsung here in Korea, SoftBank in Japan, and of course, SK, who is hosting us here today, is a very, very good partner of ours. You find that in this region, people are just as forward-thinking and advanced as they are in the US, as they are in the most forward-thinking places around the world. And so we are a little bit in chase mode here versus places like the US. But my feeling is that you are going to leapfrog over everybody else and show us the way and come up with these new breakthroughs faster and better than anywhere else in the world. Sovereign AI is a big thing. Different countries want the ability to build their own LLMs in their own language. They want the ability to have control over AI and not be dependent on other countries to do so. And we see that here in Korea a lot more than we see in other places. You have multiple options. You have multiple AI cloud providers. You have multiple ways of building in this country in a sovereign way, in an agentic way. You are leading the world in AI today. You can see that in this conference. I did not expect it to be so big. I did not expect to have so many young and curious people that understand this new world better than in other places around the world. And I'm sure that every year that I come back and see the progress, it'll be very, very impressive. We started with Korea, we'll end with Korea. And SK, of course, is our host here. SK has been a very, very good partner to VAST. From the very early days, they've adopted our platform as their data platform. They today provide AI services to end users, whether they're government end users or commercial. And what we've seen working with them over the last 2 years is that they're hungry, that they are advanced in their abilities, and that they're a joy to work with. And so thank you for hosting us. Thank you for giving us this opportunity to tell you a little bit more about our company. And anyone out there who has a lot of data, who wants to build in this new AI era, please come talk to us. We learn a lot from our customers and partners, and we try and help you build in the way that you should build in 2025. So thank you very much.